Hey, folks, and welcome to today's episode of Into the Terminal. I'm your host, Nate, and I am not joined by anyone today. So I'm going to do my best to follow chat and answer questions and whatnot. I'm going to apologize in advance if I miss anybody. So hopefully, some Red Hatters will show up in chat to answer questions that I miss. So anyway, let's hop straight on into our critical path, our demo for today. If you haven't noticed from the title of the show today, I'm going to be answering some questions that we've collected around Podman, right? These aren't necessarily in a specific theme, except that they're all about containers on RHEL with Podman. We collected some of these from Reddit. We got some from comments on YouTube and just sort of research we've done in general. So I'm going to try to get some of these hammered out. So let me get my screen share going here. All right. That's a little better. Okay. So the first question I'm going to try to address, and we have touched on this. If you remember the episode where we talked about the different flavors of UBI containers, can you run more than one service in a single container in Podman? And the short answer is yes, but I'm going to try to go into a little bit of nuance. I'm also going to show you how you might do that if you're really interested in getting that done. And we're going to talk a little bit about should you, right? Why would you do that? Why wouldn't you do that? Things like that. And I'm sure everyone's use case is going to have their own specific reasons as to why they would or wouldn't do this, but I'm going to try to cover some of the technical hurdles, right? So, first of all, the container I'm going to run is MariaDB. Oh, wait. Sorry, I've already messed up. The first question is actually troubleshooting. The other one is going to come up later. I thought about doing that in critical path and decided to move it down. This demo is actually some quick troubleshooting steps that I've got that I've learned from my container, my time using Podman containers. So let me reframe. The question here is, can you show us some quick troubleshooting tips? So I am going to make a quick container. I'm going to run through the basics of how I might build a MariaDB container. I should say pull one in from a registry. And if you're looking forward to that several services in a container thing, just stick around and we'll get to that in the deeper dive. Okay, so first of all, we're going to make a directory that we're going to store the data for this particular container in. And you've seen me do this before on the show. We're going to pass that in as a volume when we start up our container. So I'm also going to start up a container, of course. And I just wiped out my clipboard on accident. Come on, here we go. Okay, so we're going to start a MariaDB container. We're going to have it map in that volume. We see that over here. And we're just going to tell it to run. We've passed in some environment variables that are basically essential to starting up the MariaDB container with a user in a database and whatnot. So we're just going to run this. And what should happen is it's going to pull in the container. Shouldn't take too long. And then it's going to run the container. Okay, I should have pulled these beforehand. There's really no reason to wait for these to come in, but oh well. Okay, so now it gave us this long identifier that tells us that it executed, right? It ran the container. So now let's do a Podman PS, right? If we do PS, it's going to tell us what containers are currently running within Podman, and the container we just told it to run isn't running. I told you this was troubleshooting, right? So we're going to figure out why it's not running. The quickest and easiest thing to try first is to simply check the logs for the container, right? So we do a Podman logs on the container that we just created, which we named MariaDB. If you notice up here at the top, I gave it -- name MariaDB. We're going to type in MariaDB. And you'll see the output. Basically, the last thing that this particular container image does when it starts up is run the MariaDB executable, the thing that runs the service, in the foreground. So any output from that execution should end up in the Podman logs. And most containers are built that way so that the useful troubleshooting information comes to basically to the console, right? If you were running that process in the foreground. Some of them don't, but you can deal with that if you ever come to it. But basically what we're going to do is we're going to look through the error output, and we're going to see here that it's pretty obvious. We've got a permissions problem. It says can't create test file, yada, 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 permission denied. right? Now, there's a couple things that could cause that. I already see people in the chat guessing. I didn't set SE Linux contexts. Now, there's two ways you can do that. I'm going to show you the easier way to do that. So first of all, we're going to remove the failed container. And we're going to restart it. And all we're going to do is change the volume mapping here. We're going to add a :Z to the end of it. And what that tells Podman to do is the volume that we're going to map in, make sure you set the SE Linux contexts on the local file system so that they are usable by a container, right? Now, we could have verified that by checking like the SE Linux audit log, but I'm kind of going through the basics here. So if we do a Podman, here, let me clear the screen so you guys can see better. If we do a Podman PS now, it should be running, right? It still isn't running. All right, so let's check again. All right, you notice that the output is still really similar here. It's still giving us that permission denied error. So what might be the next thing that would give us permission denied? It's not SE Linux. We already fixed that. You see here, the serve-db, which is what I passed in, already has the container file T context set on it. So that should be okay. What about actual user permissions? So if we just look at ls-l on serve-db, actually, no, let's do it at the serve level. We'll see, in fact, we see it there in the other output. It's owned by root and root. Now, the thing about containers is whether you run them as root or run them rootless, the thing inside of the container has its own permission set, right? So what you're running the process as inside of your container matters. If you're running that as a user inside of the container, or if you're running it as root inside of the container, the permissions in the file system that you've mapped in need to match so that the user that it's running as inside of the container will actually be able to access those files. Now, I see Shantanu already suggesting that we should just chmod 0777. No, we're not doing that. That's the lazy way. That would probably do the job, but we're going to actually try to figure out what user we need to use. Now, there's probably lots of ways to get this done. The kind of quick and dirty way that I do it, we're going to remove this MariaDB container. Oh. Only if you type Maria properly. Now we're going to clear the screen. Now we're going to run it again, except this time we're just going to knock off the volume mapping. So let's just take that out of there. Don't want to backspace too far here. And then it's going to run MariaDB with an ephemeral volume, right? MariaDB will start up. The container image will go into an ephemeral volume within Podman, within the directory structure that Podman stores such things. And then it should start up. So if we do a Podman PS now, there we go. It's running. But how does that help us find out what ownership we need? Well, we can now get into the container and see what what ownership is on that directory inside the container image. We do a Podman exec. And this is actually another great troubleshooting thing. If you need to get into the container and look around, Podman exec is a great way to get that done. If you do Podman exec, and then we do the name of the container, we called it MariaDB, and then we just do bin bash. All right. Oh, wait. You have to run that in the foreground. There's a flag for that. -IT is interactive and in the terminal, right? But you got to put it in the right place. See what happens when I don't copy and paste, guys. I put stuff in the wrong place and it doesn't work. Okay, so now it should, there we go. Now we got it. Now we got bash. We're actually at bash inside of our container, the MariaDB container image. If I did an ls, if I typed it right, there we go. We've got a file system. Now I know that MariaDB lives in varlib MySQL, and that's where I mapped in that volume to, and that's where we need to figure out what the permission should be set to. And if I do an ls-l, you can see there's a user called MySQL within the container that the ownership should be set to. Now, if it's set to root, then the MySQL user, because it's not a root user, won't be able to write in that directory. But the problem with this is the host operating system, the place where we're running Podman, doesn't know about a MySQL user, so it needs the user ID. Now, there's other ways to get user mappings done, and it's probably a little more efficient than the way I'm doing it here, but this is the way I've always done it. So that's what you're getting. So if we do an ls-l and then the letter n, it tells it to show us the numeric IDs for users instead of the names. Now we see it's user ID 999, right? And group ID 999. So now if I get back out of here and do a podman stop MariaDB, because that was just a troubleshooting container, right? We weren't going to keep that around. We're going to remove MariaDB, and then we're going to go to serve, and then we're going to do chown. We're going to do it recursively, so I need the -r, the DB directory. Okay, now if I do an ls-l, you can see it's owned by YAML, because apparently that's user ID 999 on my Podman host. Makes me wonder if MariaDB and YAML would fight for ownership of that ID if I were to put them both on the same host. But anyway, I digress. Now we're going to run our container again with that mapping. Need to find it in my history here. That's the one without the mapping. There it is with the mapping. And we're going to run that. And now it should be working. All right, there we go. Now we have our MariaDB container up and running. And if we look at the logs, now we get output in the logs that tell us things like, hey, MariaDB's up and running. I made my database and cool things are happening. So there we go. That's a quick rundown of some of the sort of initial quick troubleshooting tips that I've got for Podman and using containers, especially for if you're not quite familiar with what runs inside of that container. Now, there are ways to get metadata and stuff out of container images, so you could have gotten answers to some of those things before you ran it. I'm never that great at making doing all that research before I start a container, so I've had to learn all the tricks kind of the hard way. All right, so let's clear that, and then we're going to move along into our next topic. But first, we have a word from our sponsor. Let me just get things set up here. Today's show is sponsored by Nate's Subterranean Colocation Services. That's right, Nate's Subterranean Colocation Services. If you're tired of hosting solutions that don't fit your needs, do you find yourself saying, I wish my hosting solution was lower effort and higher priced? Well, then we've got the solution for you. That's right. Nate's Subterranean Colocation Services. Here it is. Here is the exact service that you will receive. You too could have your services hosted in this state-of-the-art server rack, located conveniently only feet, maybe meters if you're one of those metric people, from Nate's off-road and metal fabrication services. But don't worry, there will be no welding slag and no fumes that get on your server because it's protected by that sliding glass door that's probably been there since the 50s. It may have uranium in it or something. State of the art. It will totally protect your data from any weird electromagnetic stuff that comes from welding. But you may ask, what happens if my co-located service goes unresponsive? Well, most data centers offer included service called Smart Hands. You've probably heard of this. You need someone to go hit that power button or reconnect an Ethernet cable or something, reboot the machine. Well, fear not. We offer the Perfectly Effective Technical Services, otherwise known as PETS. That's right. For a small fee, we will send this dog to the data center to press and hold your power button or wiggle a cable or whatever it is that is required to get your service back up and running. Now, you might ask, what is that small fee? Well, sometimes it's a scratch behind the ear. Sometimes it's belly rubs. But other times, it's probably whatever you couldn't finish of that sandwich you had for lunch. But rest assured, your data is safe with our pets service. So remember, With Nate's co-location services, Nate's subterranean co-location services, you may call it a basement. I call it naturally cooled. All right. So what do you think? You're going to host with Nate's co-location services? Only $1 million. I have to do the thing, don't I? That Scott always does. Okay. So thanks for coming along for the ride today, folks. I do have another quick troubleshooting thing I wanted to show you that I didn't think fit in the critical path. But first, I got to do the YouTube things. Don't forget, like if you like what we're doing here, you should like and subscribe, because if you don't, you'll never know when we go live. I see the chat is enjoying the the ad today. Thank you very much. Right. So Podman is one of my favorite topics. In case you couldn't figure that out. Usually when I get a solo episode, if it's not about Podman, you should be surprised, because it's just one of those things that I can talk about pretty quickly and easily, and this just seemed perfect for today. But I did want to show you one more thing. Let me make sure I still have things set up. I do. Good. All right. Let me get the share back up and running with the proper tab here. So there's another thing which I commonly, let me get the right share. Here we go. Which I should say it's a thing that I learned about when I went through the Red Hat Certified Specialist in Containers training, which I did, might be a year or 2 years ago. And it's a thing I didn't know you could do, but could be really useful in troubleshooting, right? So when I did that Podman exec before, that assumes that the thing I want to execute is already installed within the container image. Sometimes that's not true, right? Like there could be, and the example I got from the training and the thing that I've used this for over the years since then is, what about netstat or SS, right? Usually you won't always have that installed inside of a container image, because remember, a container image, usually you want it to be as lightweight as possible. You don't want to install utilities that aren't required, right? Now, I think that in this particular case, the MariaDB container does have SS installed, but I don't see that all that often. Most containers, they don't have tools like that installed. So there's a way you can take applications from the container host and execute them within the namespace of your running container, right? So I wanted to show you that quick because I have found it to be super useful over the years. The first thing we're going to need here is the process ID of our container process. So this I am going to copy and paste because there's like some formatting involved here that I don't want to have to type out live. So we're going to do a Podman inspect. And if you ever do Podman inspect on a container or a volume or any element that's within Podman, it'll give you a whole bunch of output. So we're also adding this -- format, and then this curly brace syntax basically tells it this is the element that I'm looking for within the Podman inspect output. And this is specifically the PID of this particular container. Now, once we have the PID, there's a tool called nsenter, which allows you to enter the namespace of something else within a Linux system, right? Now, if you were running rootless Podman, you'll probably have to do this as root. So you'd have to use sudo to do this. You can still attach to that process because those are global. Even though the root user wouldn't know about your user-based Podman containers. So you'd have to do sudo in front of this. But since I'm already running as root, we're just going to use it without sudo. So ns enter, and then we do -n and -t. I forget what those stand for, but those are the flags you need to make this work. And then you need the process ID of that container. Now you could, if you're really fancy, take that Podman inspect and take the output of it and like directly interpose it into your command here and make it a single command instead of two. But I wanted to show you the Podman inspect command separately. So what was it? 13214. And then just the command that you want to run. Now, what this will do is it'll take the executable, the SS executable from my host and execute it within the namespace of that process ID, 13214, and then it'll give us the output, right? So if I just do SS-TULNP is my usual syntax for, or my usual command line options for SS, although, yours may vary. And there you go. It's telling us that it sees a process listening on port 3306, which is exactly what we'd expect. You might ask, well, wouldn't you be able to get that from the Podman PS output? And you can see, yes, you can. There's a column here that says port. But what that's telling you is the metadata for this container, this container image, has told Podman, this is the port I listen on. That does not necessarily mean that the service running within your container is actually listening on that port. That's just the port that the metadata says. Now, if you can trust the metadata, and if everything's working as expected, then yes, that should be the port that your service is listening on. But what if you made a configuration change to the service to change the port? Or what if you passed in a configuration file that changed the port for some reason and you didn't realize that that's what it was going to do? This will help you troubleshoot that, right? So you're like, why isn't it listening on 3306? It says the service is up. Why doesn't it work? Well, this is a good way to troubleshoot and verify. Is it in fact listening on the port that you expect it to be listening on? So that, like I said, not something I use frequently, but it is definitely something that's been valuable over the years to be able to do that. And you don't have to use this with SS. You can use it with other utilities. SS is just a great example because it's pretty self-contained. I've tried to use this for things that, let me think, things that do disk operations, and that doesn't work because the disk operations get confused about being outside of their namespace. I forget exactly the nuance there, but that didn't work properly for me. But other things that just sort of read state out of memory and whatever, they work great using this feature. So there you go. Okay. So the next thing I wanted to talk about was what I almost started talking about in the critical path and didn't mean to, and that is, can you run more than one service within a container? And as I was starting in the preamble before, we did talk about this when we were talking about different UBI containers. UBI has a variant called UBI Init, and what that does is it is set to run Init as the thing that it runs when it executes, right? So when you're working with UBI Init, what you do is you install services and then you use systemctl to enable them. Now you can also take the standard UBI containers and make the command line sbin init, and it'll do the same thing or similar anyway. If I remember correctly, the systemd and the two of those are slightly different, nuanced different, but they both get the same job done. But I'm going to be using UBI Init in this particular example. Let me get to my notes here. And I'm going to, just like we did in the first example, let's clean up a little bit here. Let's remove that MariaDB container so it doesn't confuse us at all. Okay, Podman PS is empty now. Everything's gone. Good. We're going to make a directory. We're just going to call it, I don't know, my container. And we're going to edit the container file within this directory. Now, if you've never built a Podman container from scratch before, this may look a little foreign to you, but basically container file is synonymous with Docker file. In fact, I could have made a Docker file instead of a container file. Podman won't care one way or the other. In fact, you could probably name it whatever you want, just point it at the right file. But container file or Docker file are the ones that Podman will look for by default. That's why I named it that. So we're going to paste in the container file that I have pre-composed. This tells it we're going to start from UBI Init, the RHEL 10 version or the UBI 10 version of UBI Init. We're going to install MariaDB server, and we're going to install HTTPD, and then we're going to clean out the DNF cache. And the reason I'm doing that is because we don't need to carry the DNF cache into our container image. All that does is make the container image larger. And there's a lot of attention paid to how big these container images are, because the bigger the container image, the longer it takes for it to pull and deploy, the longer it'll take, or the more traffic that'll cause on the container registry that you stored it on. These are all things you just want to be cognizant of. And then we're going to do a systemctl enable on both HTTPD and MariaDB, right? Now, again, we're going to talk a little bit about should you do this in a second, but I'm here to show you, can you do this, right? So we're going to save this, and then we're going to build this container image. We're going to give it a name of my container, and we're going to give it the build context of the current working directory, just dot. So you could say if this was in a subdirectory of where you are, or say your code is in this directory and the container definitions are in the subdirectory, you could say / container directory, whatever, right? But anyway, so this is going to pull in UBI init, and then it's going to build our container out of the UBI init. Now you notice that the UBI init didn't pull nearly as much in the way of these layers here as the UBI version of MariaDB that we pulled earlier. That's because they share the same base, right? So they start from the same base image, and then the UBI init extends that, right? So some of those layers were the same, so Podman didn't pull them again, and that's actually pretty handy. Okay, so now we've got it built. If I do a Podman image list, you'll see now we've got a localhost / my container right here. And now if we run that container, just copy paste this one as well. So we're doing Podman run. -D says to put it in the background, where that IT earlier said to put it in the foreground. I'm going to give it a name, my container test, and we're going to run localhost my container. That's the image we want it to run. Notice I didn't pass in any volumes or anything, because this is just a test, right? If this thing were going to persist, you'd want to do things like put in some web content that actually talks to that database and put in persistent storage for the database. Otherwise, all that's going to go away as soon as you delete and recreate this container. So let me clear the screen here. And now if I do a Podman PS, you see we've got my container -test up and running. So let's hop into that container using Podman exec like we did earlier. My container test, and we'll do bin bash, right? And now we have a shell inside of our container. Now, how do we check if the services that we told it to run are in fact running? Well, we do it just like we would on any other Linux host or any other RHEL host that runs systemd, systemctl, status, httpd. And you'll see here that, in fact, httpd is up and running, right? Good to go. And then if we do the same thing for MariaDB, you'll see MariaDB is up and running. Now, because they're inside of the same container image, that means that, say you have a web application that needs a database backend, they can talk to each other locally within the container, right? Now, that has some benefits. Maybe you have this legacy app that you don't want to break these things apart, and that's the way it runs in production today. You can argue back and forth about whether that's the right way to run it in production today. But maybe you just want to take that thing and encapsulate it into a container and put that into a container host, right? And this is a great way to get that done. I can essentially treat UBI init very much like I would a standard Linux host. I can configure it in the same way. I can put my config files in the right places, but I get the portability of being able to treat this thing like a container. I can put that into a container registry. I can put it out across several systems if I needed to. I can map in dynamic data, or persistent data, I should say, and the thing operates like a container now. But it's not really following what you might consider container best practices, because the best practice for a container is to make each one as small as possible and make it do one thing really well, right? So in this case, we have this kind of larger container that does two things, and you could argue it doesn't do either of them really well, because you can't then take this container and tailor it specifically so it does nothing but HTTPD and nothing but MariaDB, right? You have to make it so that it does both. And slowly but surely, your container gets larger and bigger and more unwieldy, right? So yes, there's reasons you might do this. There's also reasons that maybe you shouldn't. This is just my opinion, right? If you want to do it this way, it's entirely up to you. The other thing is, one of the nice things about containers is that if somebody were to compromise, say that web application is this big convoluted, dynamic web application that's using an interpreted language like Python or PHP or something, and some attacker finds a bug and breaks out of your web application and into the host operating system. Well, in this case, the host operating system is going to be inside of that container. And if it's in the container, and your database or other private data that you probably don't want them to get access to is also inside of that container, that means they can try to get across from the compromised system or compromised application into the backend data, which might have more sensitive information in it, which you don't want them to have access to. If they were running in two separate containers, then if they break into one, the only way they get to the other is by the TCP communication between the two containers, which makes the attack surface a little smaller, right? So these are things just to keep in mind, that if you're going to try to do something this way, just keep this stuff in mind. It's just like running your web app and your database on the same host, which we've decided a very long time ago was kind of bad practice, right? So you're consider yourself warned about that. Okay. So this actually leads really well into my next demo. And let me just scan through chat here quick. If there's any questions in chat that have come up that I'm missing, go ahead and jump up and down or something. Because, like I said, I'm busy doing demos and stuff here. It's hard to follow chat. Yeah, it looks like there is some definite back and forth, but I don't see anything that's glaringly obvious as a question. Okay, so we're going to move on to the next demo. And this is actually a perfect transition because the next... Oh, looks like Shantanu has a question. Where is your question? Previous question, again, on a Mac M4, how do you confirm what OS distro is inside of the Podman machine? Of course, you'd ask a Podman desktop question. There are ways, I believe, to get a console on the Podman machine, and then you can check into that. Docs say that it's Fedora Core OS, but how to verify? I believe that is correct. I've only done a little bit of work with Podman machine myself. I will caveat that the Podman machine does not always update along with your Podman desktop deployment. So if you update Podman desktop, for example, the Podman machine doesn't automatically receive updates and get ported to the next version. I actually found that out the hard way because I was trying to build image mode containers or image mode images, and it couldn't build them. It kept giving me these weird authorization errors because the host that was running in Podman machine didn't know anything about how to authenticate to Red Hat to go get the image mode bits, right? In order to get those, because those containers require a subscription to be able to pull and to be able to install updates, because that all comes from the core RHEL repos instead of the UBI repos. So anyway, I had to go in and manually tell it to go ahead and update the Podman machine because it was running on an older version. It may be Core OS. I'm not really sure. I would have to go dig into it and find out. I thought there was a way to get a console in there, and if you can get a console, then you can of course ask it what it's running. Okay. So let me trying to clear the screen in the wrong window. Glad that didn't do anything weird in my streaming software. That would have been unfortunate. All right. So as I was alluding to, the next question is, can Podman pods replace Compose? So if you work in a Docker world, you probably work in a Compose world. That's just the way things went with Docker, right? So with Docker, well, I should say with Docker Compose, you get this YAML file. I think it's a YAML file. And it's kind of an easier way to define a grouping of containers that form up an application. And then you use Docker Compose to start up your application as a unit. And you can define the volumes that are required, what networks are required, and all of that within the Compose file. And then you can start and stop the whole thing with one command. You like bring the app up, you bring it down, you can redeploy it, all those things. There is a tool called Podman Compose, though in my opinion, there's a better way to do it with Podman. And in fact, that training I told you about, the certified specialist in containers, did teach me how to use Compose with Podman. So I did learn it. It is possible. It's a thing you can do. But like I said, I think there's a better native way to do this with Podman, which is using Podman pods, and then you can extend that into this redeployable YAML file. And I have another demo that'll show us exactly how we do that. So I'm going to go start to finish. How would I make a pod and then make it redeployable with one of these YAML files? And I didn't prepare a Docker Compose file to compare this to, but the way I normally do this is you'll go to some public project, right? And they will provide you a Compose file because that's how they assume you're going to deploy this thing. What you have to do is take that Compose file, and I believe there are tools that will convert a Compose file for use with Podman. I never do it that way. I always read the Compose file. I understand what the different things in the Compose file are trying to do, and then I manually build a pod based on that Compose file. But don't worry, that's not where it stops, right? I'm not going to say that you should just manually build all of your Compose files into a pod in Podman, and that's how you should always do it. That's only half the answer. So first, let me show you how you build a pod and how you put containers in it. So did I ever? I did not. Okay, so let's clean up again. And these commands, if you're not familiar, this says stop everything and remove everything, right? So if you're on a Podman host and you've been tinkering around and you want to clean it up, do that. It'll stop all the containers that are running and then it'll remove all the containers that you're running. So now if I did a Podman PS, you'll see there's no containers running. And if I did that with a -A, it'll still say there's none running because there's none in the background. -A will tell you if there's containers defined that are stopped. Okay, so first let's make a pod. And we'll just call it my pod. Okay, so Podman pod create, and then we give it a name, my pod. Now, if I were making a pod, I should say, if you're making a pod, you're probably going to want things to be able to access the services that are inside of there. And the way you do that is very similar to how you would in a container. In fact, let me just show you. Let's remove that one. Podman pod rm my pod. Let's just say I wanted to pass port 80 in there. We do a -p 80, hold on, 80:80. And what this would say is pass port 80 into the pod, right? And then when I bring up a container that uses port 80, that's the one that's going to listen. That's the one that's going to receive that request as it comes into the pod. So just to show you how that works. Okay, so now I have the pod created. Let's put some containers inside of the pod. So first of all, we're going to put a HTTPD container in there. And this run command is going to look pretty much identical to if you were running just any old container, except I'm adding this --pod subcommand that says link it to this pod, right? And if I had a volume to map in or something, I would do that here, but I would not specify ports that I want to pass along, because normally you would do that with a container, but I did that at the pod level. Like I said, the pod will be able to access whatever ports your containers listen on, but the pod then works as almost like a boundary firewall, where it says, okay, ports that I don't care about, they don't get into the pod. Ports I do care about, they go to whatever container is listening on a given port. Okay, so I'm going to run that one. And you might have noticed we're sticking with a similar example to what I did in that multi-services container build. The next thing we're going to do is we're going to put our MariaDB container, the exact same one from earlier in the demonstration, inside of this pod now. So let me clear this so you can see what I'm doing. And you can see we're going to do a Podman run. This is the exact run command we did earlier, except I'm adding the --pod, my pod right here, right? So you can see where I have that added in here. Otherwise, this is the same run command we used to run the container earlier. Okay, so again, it just gave us that ID back. That means that it's running. If I do a Podman PS, now it shows us we've got the MariaDB container running, the HTTPD container running, and we've also got this infrastructure pod, right? You see this localhost /podman-pause. This is like an empty container that simply runs the network, right? And the sort of pod containerization that goes along with making a pod, right? And the thing I like about Podman pods is now I can treat the containers like an individual entity, right? So all of these containers that make up a service, the web service and the database backend, are now grouped inside of this thing called a pod. So I can do things like start and stop that pod. It gives me this status here. See, it says status running. If I had excuse me, if I had defined health checks for those pods, which is a thing that Podman can do, if I defined health checks for those containers, then if one of them failed their health check, it would tell me in this status. If one of those is down, what did I call it? Did I just call it HTTPD? Yes, I did. If one of those containers is down within my pod, and then I do a Podman Pod PS, it actually tells me it's degraded. And it'll tell me that there should be 3 containers. I thought it told me that there were 2 out of 3 running here, but it doesn't. Sorry. But it tells me it's degraded, which means that there's a container that it expects to be running that is not running, right? So now I can, I have one of my containers down. I can do a Podman start, or pod start, sorry, on my pod. And what that'll do is, if I typed it right, I saw a comment before we started the show about somebody feeling they feel comforted when we do typos on the show because it makes them feel better. So you're getting plenty of that today. My pod. Okay, so we're going to do a Podman start my pod. And what this will do is it'll say containers that are within my pod that aren't started, go ahead and start them up, right? And now, assuming there wasn't a problem with that container that it couldn't start, it'll start up and it'll say it's running. I run into this sometimes where if I have 2 or 3 things that are dependent on each other inside of a pod, unless things have changed. The last time I looked into this, Podman doesn't really give us a way to define dependencies, right? So this one has to start before that one, or this one has to pass a health check before that one. It just isn't that advanced. So sometimes I'll run into a case where the pod comes up, the one thing comes up before the other when it should have been the other way around, and because of that, one of the containers within my pod fails to start. And the easiest way to fix that, once you've identified that that's the problem, is to just do a Podman start on the pod and up it comes. So I've, for applications I have that commonly have that problem, I just have a script that runs every so often to check the status, and it'll run the it'll rerun the pod or rerun the containers that were failed. And if that fails, then you have a bigger problem. Okay, so and like I said, we can also like restart on the pod. Right. So if I did a Podman pod restart, it's going to go through and it's going to stop all the containers and bring them right back up again. If I did a stop on the pod, it'll also stop the pod, right? Oh, pod stop, not just stop. You have to go into the pod subcontext, right? And if I do a Podman pod PS now, you should see that it says exited because we cleanly shut it down. But this only gets us part of the way, right? This gives us a unit within Podman that we can treat as treat our entire application, including all of its dependencies, as a single unit, which is great, but it doesn't make it redeployable. And the one thing that's really cool about Docker Compose is you can take that compose file, and as long as it's written in a generic enough way that it's compatible across several systems, obviously that's not always true when you're doing things like defining volumes and whatnot, but you get the bulk of that application defined in an easy to read YAML file, which you can then just make the little tweaks that are needed for your particular systems. And if all of your container systems are designed the same way, it should mean it's portable from one to the next. Or if you have it map in volumes that are, say, on a networked volume instead of local, right? But just making an application into a pod doesn't get us that. So there is a tool that'll help us do that. And it's not even a tool, actually, I should say. It's a feature of Podman. We can tell Podman to generate certain things. For example, I can tell Podman to generate a systemd unit for a container so that I can then plug that into systemd and it'll start that container every time I start my machine up. Or I can just interact with the container through systemctl instead of directly through Podman, which is helpful when you're trying to sort of enterprise up your containers, right? But there's a tool we're not going to talk about today, but something you should be aware of, called Quadlet, that'll also do that for you. You can make these YAML definitions in Quadlet, and then you can deploy stuff that way too, right? That'll talk directly to, it'll generate a systemd unit. Systemd can then start up your containers. I don't have a demo ready for that today, but with Quadlet, you can also deploy an entire pod using a YAML definition, which is also something that Podman can generate for us. So if I do a Podman generate kube, K-U-B-E, because this is compatible with Kubernetes, which is why it's defined this way. And I tell it what to generate on my pod. And you can do this for volumes or individual containers, whatever. We're going to do it against the pod because that's what I care about. And it just outputs it to the screen here that, here's the pod. This is what this would look like in this YAML definition, right? And the cool thing about this definition is that I can now take this and move it to other systems, right? But this just outputted right to the screen. So let's say dash file name .yaml, right? So dash file name mypod.yaml says output this to a file instead. And now we can open this up in Vim or whatever your favorite other incorrect text editor might be. And now we get the benefit of syntax highlighting and whatnot. So some of this metadata that's in here isn't necessarily important to include in your redeployable files, like the creation timestamp. I don't know if I really care about that all that much. It's good information to have if I'm versioning these things or something. But anyway, I digress. So this is defining an item that is a pod. It says kind pod right here. And it's got this metadata, right? And you can see that it's got a mention of our binding, our mount binding in here, which is helpful. But if we go down, you can see where it says labels, the app, and the name. This is what tells it what to call the pod when you deploy it, right? So using that file, using that syntax, you could change this if you wanted to. If you're deploying several of the same thing, you just change that name and it should come out the other end with a unique name. Then it goes into the actual definition for the containers, and each of these are an array within the YAML definition, right? So you can see here that the environment that I had defined, and there are ways to take these environment variables and move them to a separate file, or you can use Podman secrets instead of putting these things in here plain text. Again, I'm not delving into that today. And then we've got our MariaDB container, and it tells it what, sorry, I should say we have the HTTPD and then the MariaDB container. And then, of course, here we have those volume mounts, right? So there's a block within the MariaDB container that says, this is where you're going to get varlib MySQL from. And it uses an actual, it's very similar to how a PVC works in Kubernetes, right? A persistent volume claim. It defines the volume separately down here instead of just this directory mapping, right? This is just how the YAML makes it happen. And then down here, of course, is a host path that says mount/serve/db to this hold on, I'm not at the bottom of the screen here. That's why I can't find the name. To this name, serve db host 0, and then it says to take the volume called serve db host 0 and map it to varlib MySQL within the container, right? So now what we can do with that here, right? If we do, I didn't remove that yet. We're going to remove my pod, right? And what this will do is it doesn't just delete the pod definition. It actually gets rid of the containers that are within it, right? Okay, now we have no more pods. If I do a podman play kube on this file, this mypod.yaml, what it'll do is it'll read that YAML back into Podman and redefine all those things that were within that YAML file. And now we have my pod back and the containers that were within my pod. And when you bring it in this way, it actually names the containers in a way so that it's not going to be easy to accidentally get container name conflicts. It names them all with this. It puts the name of the pod and then a dash and then MariaDB, right? So this is a thing you might want to keep in mind as you're defining your pods. I should say as you're defining the container names. Otherwise, you're going to end up with these crazy long container names that if you need to work with a container name directly, it gets a little unwieldy. So that's just like a nice thing to keep in mind. All right, and the comparison here to Docker Compose, yes, it's different. I have seen a couple of projects that were publishing Docker Compose files are now also publishing these definitions, because these can be modified and used in Kubernetes as well, right? And that's also a thing that a lot of these projects were already doing. So now they're just making one more slightly stripped down version of the same file to let you deploy this stuff in Podman. I think it's really handy that they're starting to support more than just Docker, because Podman needs some love too. I name all my pods test. Thanks, William. Thanks there, Billy. Okay, so let's see. Do we have any more questions that came through while I was going there on my little monologue? I see a bunch of questions that were answered. I see more stuff about Podman Desktop. So go ahead and jump up and down again if you got any questions that we didn't answer. Or I should say I didn't answer. And remember to go sign up for Nate's Subterranean co-location services. My dog is hungry and she wants to go fix your servers. Okay, well, what I'm going to do then is we're going to close up the share here and close up the show. Folks, I want to say thanks for coming today. We did not yet plan out our next episode. However, I want to tell you that next Friday, both Scott and I are going to be unable to do any show because we're traveling for work next week. Both of us, there's a team meeting. And he's going to be busy doing like recordings on Friday, and I'm going to be on an airplane. So it's kind of hard to do a show that way. Although we could try. It might come out a little less polished than usual. Today's show aside. But yeah, it'd be hard to do from an airplane. It's just the Wi-Fi is never good enough up there. So we will see you again in 2 weeks, and we're up in the air as to who's going to be hosting then, because I'm just returning from a conference in 2 weeks. So I may not be available for the show or not, but we'll see. Scott and I will figure that out. Somebody will be here to do a show the week after next. So we're only going to miss the 1 week. And with that, folks, remember to like and subscribe. Make sure to leave some comments if you have any comments that you'd like to leave. And we love hearing from you all, right? Everything's growing and we love it. We love it when people show up to watch a show. We love it when people leave comments so that we can hear from folks. It's just, it's good. It's good. Just spreading the word. All right. Well, thanks for coming, folks. And we will catch you in not 1 week, but 2. We'll see you then.